Hello, my name is Amy Cox, and I'm working with Dr. Reed in the Alabama Phonetics Lab on a project entitled Variations Across the South. In this project, we are looking at analyzing specific speech sounds in order to compare the Appalachian dialect to other dialect regions. I'm going to get you started by going over some background information about what we are doing and why we are doing it, before delving into the methodology and results and concluding with the future goals of my research. So to get started, I'm going to define where exactly we're looking, because Appalachia is often ill-defined and it has a lot of internal variation and differences. So in particular, within these 410 counties in 13 states, we are actually only looking at a few counties up in northeast Tennessee to fully capture what this specific dialect looks like compared to other dialects within Appalachia and within the country. And so to get started about why we study language variation, there are two key reasons to study language variation. The first is for a clinical application by speech pathologists. This is for an understanding of why language varies in order to apply that to diagnoses and to clinical treatment plans, because you have to understand what are natural processes for a specific region as compared to what is an actually disordered speech, because those two things aren't the same and shouldn't be treated as such. The second reason to study language variation is for a sociological understanding of how people vary. And for speech in particular, this is how speech production varies when looking at factors like age, race, gender, or ethnicity. And while all this might seem very big scale, this is in fact looking down at the individual sounds and the differences in how these are produced. And in order to identify those sounds, we are using a process called forced alignment. This is using a computer program in order to go through an audio file to identify what specific sounds are within the specific speech sample. And within the field of forced aligners, I'm using one called the Montreal forced aligner. We chose this one among other forced aligners because it allows for both a standard preset dictionary model as well as the ability to adapt them to specific regions and dialects. And so to look at an example of what this would look like, this is a full output of what I would see in my research. However, this is a lot to take in, so I'm going to break this down bit by bit. So the first thing you're going to be looking at is your audio file. The top row being your standard waveform. This is what you see when you record on your cell phone or any other microphone device. Underneath that is your spectrogram. This is a very important analytical tool because it allows for the quantitative analysis of speech, which is very perceptual in nature and thus typically very qualitative. So you're able to get quantitative measures to compare such things like frequency, intensity, and duration, which then you can average from speakers to compare to other regions as well. And the next row, you're going to look at your orthographic transcript. This is your standard written English, and the computer uses this in order to identify what sounds it needs to be looking for within this file. And to do that, it uses a dictionary and an acoustic model. The dictionary is a very long file with almost every spoken word in English and the pronunciations of these words. And so for an example of that with a common word like a, the dictionary would see this word within the file and then have to determine, did the speaker say a or because both pronunciations are used depending on the context what the speaker is talking. This can also deal with variations in regions where people speak. So with a word like pecan, it can be said 3 different ways: pecan, or pecan. And so the computer has to take that written word and understand how that specific speaker is saying those sounds in this instance. And once it identifies the sounds within the word, it goes through an acoustic model. The model is trained to understand what speech sounds are within specific contexts in words. And so currently the one that we are using was pre-trained by the University of Montreal. They used 2,484 speakers across 19 hours of data in order to get a very wide range of understanding on dialects. And so going back through this, we talked about those rows, and we haven't yet touched on this bottom row, which is probably the most important because this is the individual speech sounds. So you can look at this and go and get those measurements from that spectrogram. And so from this, we can get values on the vowels and average those from speaker to speaker, region to region, and then get those measurements to compare to and to apply those to different dialects. And so going through this process, I have done this 20 times with files ranging from 45 minutes to an hour long, and I'm currently going through and checking to make sure if it's right and to see how it's going. And so looking towards the future, I'm going to train a new acoustic model that is specific to Appalachia to compare the results and try to expand because we can look at more data faster. So thank you for listening to my presentation. Do you have any questions?
So earlier you showed us a map and it had the Appalachian region. Why did you choose to study this particular region as opposed to all others?
Yes, thank you for that question. So we chose to study Appalachia in particular because it offers a non-mainstream dialect, which then we can use to compare the models and see how the aligner does. So the aligner offers a lot of ability to capture. Currently the one we are using that's pre-trained captures it 90% of the time, and we did not know this going into the project, and we did not expect it to be this well with how it captured the dialect. But it also offers us the ability to train the model on this non-mainstream dialect so that we can then compare to see how training a new model will do for this.
How will the creation of a new acoustic model help?
So it will hopefully pick up more nuance within the speech. So because it is a non-mainstream dialect, there's going to be differences in how there's specific pronunciations. Like I think the one that I ran into was the words that start with W, when. A lot of, in Appalachia, it happens a lot where they say when, and they have that H sound at the beginning. So this will hopefully pick up that better when we train a new model that knows to look for that.
Where are you getting the sound files that you're using to analyze? Like, are you going to Tennessee to get them, or are they being recorded for you, or how's that?
So the ones we're using right now were recorded by my research professor. So these were recorded a few years ago, and they've already been done in this region, which is another reason why we chose to look here first, because we already had those files. But we can also look to expand and record in Alabama and other regions in the South, and that then it would be going out and doing field work to make new recordings.
Thank you, Amy.